In this video, we will learn how copper to oxide is reduced by hydrogen gas. Many learners fail to understand this topic not because they are dull, but because they miss one concept. To understand this one concept, follow my Facebook page, stay tuned, and pay attention. Obviously, we don't want to keep coming back to this video, so let's understand this once and for all. Reduction of copper to oxide take place in 3 stages. Stage number 1, production of hydrogen gas or preparation of hydrogen gas. Stage number 3, dehydration of hydrogen gas or drying of hydrogen gas. Stage number 3, reduction of copper to oxide. Let me remove these other highlights so that we can focus more on preparation of hydrogen gas. Preparation of hydrogen gas is taking place in the rounded flask. We can see the Bunsen burner. The function of the Bunsen burner is to produce heat. So heat helps the reaction to be faster. In the standalone premium lesson, we covered 20 common reactions in chemistry. And one of the reactions was between metal and acid. We said acid plus metal is equal to salt plus hydrogen gas. So therefore, we are going to say our first stage of the reaction is preparation of hydrogen gas. In our case, we can see that the metal that we have is zinc metal and dilute acid. We are going to say zinc plus dilute acid is equal to hydrogen gas. To understand better what we are talking about, let us come up with the word equation and chemical equation. We are going to say zinc plus hydrochloric acid. So the dilute acid in this case is hydrochloric acid is equal to zinc chloride plus hydrogen gas. This is the word equation. Let us also construct the chemical equation. We are going to say zinc plus hydrochloric acid is equal to zinc chloride plus hydrogen gas. We have two products, zinc chloride plus hydrogen gas. The essence of this reaction is to produce hydrogen gas. We can see bubbles of gas here. These bubbles of gas are representing hydrogen gas. It turns out that the hydrogen gas produced in this rounded flask has some traces of moisture or some traces of water. Now, where will these traces of water go? To answer this question, let us dive into the second stage of the reaction, which is dehydration of hydrogen gas or drying of hydrogen gas. To dry hydrogen, we need to use dehydration agent. We have 3 drying agents here: silica gel, concentrated sulfuric acid, anhydrous calcium chloride. So we can use one of these three drying agents to dry hydrogen gas. In our case, we are going to use anhydrous calcium chloride. We are going to permit hydrogen gas, which is embedded with some traces of moisture, to pass through anhydrous calcium. Anhydrous calcium will remove some places of water or some places of moisture from hydrogen gas, and dry hydrogen gas will be produced. The dry hydrogen gas will proceed to the next stage of the reaction, next stage of the experiment, using this glass tube. Let us move to the next stage of this experiment, which is a reduction of copper to oxide. Dry hydrogen gas plus copper to oxide will lead to production of pure copper and water. In this case, we have seen that hydrogen gas has removed oxygen from copper to oxide, and water has been formed, and pure copper has been produced also. So we can clearly see that hydrogen gas is acting as a reducing agent. At the same time, hydrogen gas is acting as an oxidizing agent. Pure copper has been produced. It is the hydrogen gas that has grabbed oxygen from copper to oxide. Let us construct wave equation and chemical equation so that we can better our understanding, or we can understand properly what is taking place here. So we are going to say copper to oxide plus hydrogen gas is equal to pure copper plus water. We also construct the chemical equation. Copper to oxide plus hydrogen gas is equal to pure copper plus water. So we can clearly see that hydrogen gas has removed oxygen from copper to oxide, and copper has been left alone. So this is pure copper plus water. The next thing that we need to be familiar with are these two terms, reduction and oxidation. Let us start with reduction. What is reduction? Reduction is the removal of oxygen from the compound, or we can say reduction is the gain of electrons. So in this experiment, we have seen that copper to oxide loses oxygen, so it is reduced. Copper to oxide has lost oxygen, so therefore copper to oxide has been reduced. Let us also understand oxidation. What is oxidation? Oxidation is the gain of oxygen, or we can say oxidation is the loss of electrons. Let us differentiate these two terms. We are going to say reduction is the removal of oxygen, while oxidation is the gain of oxygen. Let us confuse these two terms. So let's be mindful of that difference. What observation are we going to make from this experiment? Or what have we observed from this experiment? So initially we had copper to oxide, and copper to oxide was looking black. Then we permitted this copper to oxide to react with hydrogen gas. Then at the end of the experiment, we saw production of pure copper or production of water. So we have seen that the reaction of copper to oxide, which is looking black, plus hydrogen gas, has led to production of pure copper plus water. To understand better the observation, let us have this table here. The name of the gas produced, hydrogen gas. So in this experiment, the gas that was produced is hydrogen gas. Initially, the color of copper to oxide was black. The color of copper to oxide was black. The solid product or the solid substance produced is copper, pure copper. So copper to oxide was reduced by hydrogen gas, or we can say copper to oxide was reduced to pure copper. The type of reaction is reduction. The type of reaction is reduction. To appreciate the importance of what we have learned, we are going to answer this question, which is coming from 2024 past paper, science paper 2. And this question is question A14. Question A14 reads, the following diagram was designed to carry out an experiment on copper to oxide. We can see the diagram here. The question continues, which of the statements is correct about the chemical reaction in the experiment? The first column, we have gas from the flask. The second column, we have color of copper to oxide. The third column, we have solid product in heating tube. The fourth column, we have type of reaction. So we have seen that the gas being produced here is hydrogen gas. Color of copper to oxide, we saw copper to oxide was black. Then the solid product in heating tube was copper. Type of reaction is reduction. Our correct answer, therefore, is A. We have come to a close. Peradventure, there is a question. You are free to drop that question in the comments section.